So the question we want to ask is, what do forces actually do? We've got our free body diagrams, drawn our forces. What do they do to the object? So the effect of forces is that they make things speed up, slow down, or change direction. It's really that simple. Now, how this actually happens is the subject of Newton's second law, and I want to actually write it down this way. So Newton's second law basically says the net effect of all the forces acting on an object the net effect of all the forces acting on the object is to make it speed up, slow down, or change direction, provided those forces do not balance. And we're going to kind of take this abstract principle and apply it directly to problems on this and on the next page. I'm actually going to give you a procedure for force problems in a second. So there's actually a process we're going to use to figure this out. So let's actually go to our first numeric problem and take a look at it. So we have a 2 kilogram box pushed with 10 newtons of force, and it experiences 2 newtons of friction. What is its acceleration? So let's just kind of label a couple things. Kilograms is what we measure mass in. This is the applied force that's measured in newtons. That's the unit. Same here, we got a little friction force. So let's go ahead and draw the free body diagram and use that to construct the mathematical solution to this problem where we want to figure out the acceleration. And by the way we write Newton's second law numerically, this speeding up, slowing down, changing direction, there's a word for that. It's called acceleration. So to write this law mathematically, what we basically want to say is that the effect of all the forces, meaning you add them up, this means addition from your math classes, and the effect of all those forces acting on the object is that it makes the object, that's mass, accelerate. They don't balance. So in this case, let's draw the forces. So we've got the normal on big M. I've got the applied force F. I've got the weight of big M. And I have this friction force in the other direction. Now, what I mean is that I'm going to actually read my equations I'm going to figure out what my equations are by looking at this picture here. So I have the normal on big M. It's in a tug of war with weight, and the effect is they balance. In the horizontal direction, I apply the force to the right. The friction force acts opposite, and the effect of those two forces having a tug of war is that the mass actually accelerates. This equation is true, but it's not necessarily helpful right now, but we can solve for the normal force. The normal force equals the weight, and the formula for weight is going to be 2 times 10. Again, that's m times g, so I get 20 newtons for the weight. Now, to get the acceleration of the box, I have a 10 newton force, 2 newtons worth of friction. I'm pushing a 2 kilogram box, and I want to get the acceleration. So when I rearrange, I'm actually going to get that my acceleration is 4 meters per second squared. We're going to tighten up this procedure in the next video to actually have a recipe for how to solve force problems that'll be useful both in my class and on the AP.